So I'm like super pumped. So first off, let me just get some of the simple stuff out of the way. I'm at Juniper, started Monday, loving it, and I'm actually really, really pumped because like everything I've been thinking about prior to joining Juniper, I joined. One of the reasons I joined was because I knew that I was like really in sync with some of the things that I was thinking about and working on with a lot of the folks here. Today, like just that hammered that point home. I'm more aligned than ever with everybody here than I thought I was. So something's going right there. Like I said, I've been at Juniper for 3 days. What that means is that, I can kind of mess up and I have an excuse. So I'll do my best, but who knows? What I'd like to talk about today, sort of really briefly, is just sort of like, I wanted to draw inspiration from a few of the things that I was working on, prior to joining, some of the conversations I've had here, and really just get people excited about building stuff. One of the things that the whole team this morning has really hammered home is the idea of building infrastructure in a way that has really good abstractions on top, really good tooling on top to solve some of the really hard challenges, but not in a way that sort of limits what you as a builder, as an engineer, can do. And this is just sort of like a fun play on that, and just kind of give you guys something to take home and play with. So hopefully that'll be interesting. So I do want to talk about intent-driven networking. This is the ideal form of intent automation. I don't know if that's really applicable, but it's certainly on my mind. No. So what I want to do is I want to hit off a few sort of key topics, and just like I said, I've been working on this presentation for the past like 2 weeks, and I'm just really excited because everything that I'm about to talk about we've been talking about today already, and I'm really excited to be so well aligned. So like one thing I really want to hit on is talk about what intent really actually is to me. Like you'll hear people say like, I want to run this app, Crisis on Kubernetes. I've never done it, but I'll try now that I've put it in a slide. You have to think about what it is that the application developers are doing and where they're deploying and why they're deploying in those places like Kubernetes. And to me, the conversation around network automation has always, the progression has gone in a really good direction. Certainly in the past 5 years around network automation, we've really changed the conversation. And one thing that I really would love the conversation to catch up with is the idea of using the infrastructure itself as a source of truth. I really strongly believe that the infrastructure is what it is, and we can build templates and YAML files to describe what we'd like. But the reality is that WSBE versus weary comparison, what it really is, what it should be, it's never going to be what we want it to be unless we use the network and the infrastructure broadly, including the applications, as a source of truth. And so some of the things that I want to talk about today and demo is literally using that infrastructure as your source of truth. So we're going to do some cool automation stuff, but we're actually using the infrastructure itself as a source of truth. So a few things on this. Like I said, the intent is there. Right? The applications themselves, especially on modern platforms like Kubernetes, they're already describing what they need, right? There's, we've talked about maybe getting the applications to talk to the network and tell the network what they want, but the reality is the applications are self-describing now. This didn't used to be the case, but they are now, largely, even before Kubernetes, but especially when you talk about applying infrastructure as code to describing how applications are laid out, different components of different applications, it's all there. The infrastructure has that information and we can go query it. So the intent of the application, in my mind, is primary. We do talk about intent-driven networking a lot, and the intent of the network engineer isn't unimportant, but in my opinion, it's sort of secondary to the intent of the application. And in many ways, the intent of the network engineer can and should be informed by the intent of the application. So really just ignoring one of those things doesn't really get us where we need to go. I think we need to sort of rely on each other. Developers, when they deploy applications, specifically, SREs, especially when they deploy applications to platforms like Kubernetes, they don't really care about the network. They barely care about the sort of the virtual network services that are attached to their applications. They know about, I need to speak HTTP between these two sort of microservices. I need to speak, some sort of messaging protocol between these other two. That stuff's fine. But what they really rely on is these abstractions that sort of, Bakash was touching on earlier today. I just expect that when I feed this data into this API, I'm provided with this service. And I think that's super important. Because really what you're talking about when you talk about declarative infrastructure, that's one of the things Kubernetes folks really hit on a lot, is I just want to describe how things are laid out, and I expect all of the infrastructure to use that information. Not, hey, I've provided the infrastructure, or I've provided the application manifest, and I got to do all of this other stuff to make it happen. It's that very declarative, here I am, please provide me with the services you're promising, that kind of thing. And the corollary point to this is AWS doesn't make you configure their switches. You deploy your application using their abstractions, their APIs. All of their actual under the hood infrastructure comes up to meet that. So I think that's super important to think about. And when I talk about the cycle of, and I'm going to get sort of into my specific topic, and a few of you guys, if you followed me for a little bit, you know that I've been on this hobby horse for a while. This idea of doing continuous deployment and testing for networking, it's a cycle that just is constantly ongoing. And it's a multidimensional cycle. It's just like this could be applied to one part of your network, and you'd have a totally different cycle for another part of your network. But the cycle is there. You constantly need to be gathering the intent, again, of the applications as well as your network. You constantly need to be applying that policy based on that original intent. And then the most important, they're all important, but the most interesting thing to me is that you constantly need to be verifying that that policy is being applied in the way that you think it should be, more specifically in the way that the intent is describing that it wants. I also want to touch on this. API is the new CLI. Now, I say no to answer this question. It's a little bit of a pedantic thing. I believe very strongly that API-driven infrastructure is important. It's the title of this talk, so obviously I believe in it. The question, API is the new CLI, has come up so many times over the past few years. And I think that the raw comparison between the two misses the underlying point. And that is that CCIEs aren't going to be running around configuring the network devices with curl, right? And that's not sort of where the conversation needs to go. Where the conversation needs to go, in my opinion, is how important, what does an API-driven infrastructure represent in terms of a paradigm of how infrastructure is run? And I bring this comparison between sort of like 5 years ago and a little bit now, and certainly in the next 5 years, of the transformation of not even a network person, but even just a generic sort of like systems administrator. James was talking earlier about the rise of the SRE. It's the same sort of transition in terms of role. Previously, we'd have to have human beings as, and I know Drew loves this term, but I actually, I said this term first on a Packet Pushers podcast with you and Ethan. I call it human glue. It's, take that as you will. But honestly, like, this is sort of what we've had to deal with for so long. If you had to apply policies, and there's no, especially these days where network infrastructure and infrastructure in general is so heterogeneous, there's just no getting away from having to translate something that is in one format to another format. And guess who does that? Human beings, fingertips, keyboards, the whole shebang. We've all been there. The big transformation for me, and this happened with the whole SRE thing, it's happening with network folks, James hit on this, is that all of these interactions still need to take place. All of these different parts of your infrastructure still need to communicate with each other. It's just the reality of running heterogeneous infrastructure. Except that now what we're seeing is a transition to those interactions taking place programmatically. That doesn't, and this is the part of the conversation that really bugs me whenever it comes up, it doesn't make this person irrelevant, it moves them out of the actual flow of that transaction. It just changes the role. And so this person now monitors all of these interactions, maintains the business logic and the rules about how these components should communicate with each other, and then, this is the part that really interests me, filling in the gaps with scripts and open source software. Right? We've talked about doing open source and networking for a while, but I think the conversation is now finally settling to a point where it's not about boiling the ocean anymore, and it never really was. But we're talking about it in that way, in that very pragmatic way now, where we're actually saying like, yeah, the role changes, it doesn't go away, but the role changes. And I think that's really important to think about. And so all these systems now are talking to each other, and all of those interactions are taking place in an autonomous fashion. And so we have a unique opportunity to sort of sit above that and try to figure out where we can provide value across the system instead of in just one sort of component. And this is another part where I'm really excited about how well aligned everybody here is. Like the idea that all of the infrastructure is API programmable. We have products that do the management, the visibility, the security thing. That's great. It certainly answers a ton of questions and a ton of use cases, but it's built on this platform that doesn't hold you out, doesn't box you out from doing things yourself. And so alongside all of this stuff, you can build your own scripts, you can use open source software, off-the-shelf stuff. It's your infrastructure. So we build things in a way that's just really, really open in that way, and it's refreshing. I certainly know in the past 5 years, I've seen a ton of growth in that. Okay, so what I want to get into, and I'll try to show as much of it as possible, but I'll tell you everything that I've built is on GitHub, and you can download it. There's a few things you can build if you look at this paradigm of API-driven infrastructure, and then couple that with the fact that everything's just open and usable to you. And one of those things, and I've been on a few of these things lately, auto remediation, the idea of taking action based off of predefined rules, instead of, again, you being plugged in as part of the actual flow of that interaction and like a load-bearing component of the system. Instead, you can say, look, software is not magic. I can write a script that describes literally the exact same logic that I would normally apply myself, but just as code. And it's sort of the acknowledgement of and the demystification of that. Streaming telemetry, I actually, I was originally gonna look into building a really cool, GitHubable demo. Turns out the guys at NFT14 beat me to it, so definitely go back and look at that video. Fantastic demo. And it really highlights, again, a lot of the really cool stuff you can do when you open everything up and expose yourself to like using these open source tools. And so anyway, that leads me to the third point, automated verification of network services. And again, detailed, not just pinging where things are at. We've done that for a long time. I want it to be autonomous, I want it to be automated, and I want it to be detailed and repeatable is the big thing. That's 4. I swear I can count. So that's what I would like to talk about real quick. And leading into the verification, again, this is all automated and this is all continuous, right? Always be verifying. Before you get started on this path, what you really need to know is what it is that the services, what they actually want out of the network and where they need to communicate. And I saw this tweet recently by Mark Imbriaco. Basically, the very first thing you need to figure out is what it is that tells you that your network is down, right? From the perspective of the users, it's super important to look at all these interface statistics and obviously get all the dashboards. That's great, but the step one needs to be what it is, the services that your network is providing. In enterprise, that's a really complicated answer because there's all kinds of applications. I'm not going to say that that's like an easy thing to do, but just changing that mindset and trying to figure out like what are the really important things that are relying on my network, and how can I make it just stupid accessible to all of those different business units to at least see that that's happening, and not in like a dashboard like kind of like here's the thing way, but like here are the tools we use. You can use those same tools, by the way. It's an API, and we built the API, and it works, and you have access to it. It's kind of the same premise of everything that we build at Juniper, where everything's API accessible. We're all adults here. Use your infrastructure, and so it's kind of the same premise, and I really appreciate that. So there's 3 stages of verifying the things that the things that go across your network, and I always talk about these different 3 axes because they're all important. They're just important to different groups and for different reasons. The first one is verifying the config. I know what the config should look like. This goes back to sort of the WSB versus Weary comparison. I have a golden config. I know what it should look like. Is it that? If it's not, then maybe have a conversation with somebody. But yeah, that is the first step. And obviously that's super, I say selfish, that has a negative connotation. Obviously network engineers care probably most about this. That is their interface to network devices. Network state-centric is the next one. This is still pretty network engineering centric, but it's a little more realistic just because it reflects a little more of like the current state of affairs on the network. And then of course there's application-centric verification. This is, again, what I think is sort of the most valuable and should be that sort of the center of the universe in terms of how do I know that my network is providing the services it's supposed to. So I have a demo. The topology here is real simple, obviously. I have a little bit of a VM here, just a Ubuntu box, VSRX, so we spin both of these up with Vagrant. And then Minikube, which if you don't know about Minikube, it's basically like a stupid easy way to set up a POC for Kubernetes. Literally one command, like Minikube start. I have a Kubernetes cluster, done. So super awesome. I have deployed everything in a GitHub repo. I've uploaded everything in a GitHub repo, and I can show you that now, actually.
I like the demo failure tag at the bottom there. That's good.
Oh, yeah. No, yeah. So, yeah. It will succeed in failing, is the point. So this is the GitHub repo. If you can't read it, I can make it a little bigger. It's just my username, Mierdin, M-I-E-R-D-I-N, and then /NFD17 net verify demo hyphens are there. So feel free to check that out. Literally everything that I built is in there, and the whole demo walkthrough is in the README. So you literally just copy and paste and get all of this really cool stuff. Now, I've done a few things ahead of time just for the sake of time, but I'll talk you through it. There's a few things. First off, I have let me open my editor real quick. I have a config firewall.py script, and I have a verification demo.py script. Both of these scripts refer to a kas.py, which is a thin wrapper on top of the Kubernetes Python library. What I'm doing here is I'm saying, look, I have this application deployed in Kubernetes. What I really want to do is I don't want to maintain YAML files that say where the application is because they'll probably be wrong in 5 minutes. What I would really love to do is just figure out where Kubernetes is, and anytime I need to make a change, pull it for the source of truth. Hey, what are the services that are running on them? What are the node IPs? What are the ports? What are all of these pieces of information that I need to generate policy for my network? Get it live. So that's what that does. What I will show you next is this verification demo.py. Again, this feeds into that same backend Kubernetes code that I wrote to retrieve the services that are running on Kubernetes. And what this does is it says, okay, I see the services that are running in Kubernetes. The other script built policies and configurations to make it work and pass traffic through the VSRX. This one uses that same information to verify that those things are accessible from endpoints outside of the firewall, right? So if we go back to the demo topology, you can see that I have this VM, and all of these verifications will be running either on my laptop or the actual traffic verifications are running here. So they actually pass through the VSRX to get to Kubernetes. What we're verifying is that we actually have the connectivity that we need based on what we asked Minikube or Kubernetes that it needs based on the applications that are deployed. So let's do that. So what I have here is, and hopefully that font is big enough, I can make it a little bigger. First off, let's just do kubectl get pods and kubectl get service. So there's a few things running here, and for those that aren't familiar with Kubernetes, the guest book is just like the hello world of Kubernetes. It's real easy to deploy. I replicated all of the application manifests and whatnot in the repo, so they're all there for you. Basically, it's just a little front-end service that records messages and displays them that are stored in a database. And we can actually do this. This is in the walkthrough here. You can just do Minikube service front end. It's sort of a Minikube cheat. You can type that in, and it opens a browser and shows the application. So you can just type, I had hello NFD17 in here, hello again, submit. So pretty simple. The demo isn't about that, obviously. What I'd like to just demonstrate is that we know that we can reach it, again, based off of the API, the things that we retrieved via the Kubernetes API, not some YAML file that I stored and expected to stay up to date. So I ran the verification demo script a few times. The whole point of running it now is the policies that allow Kubernetes connectivity from the Bastion VM actually haven't been applied yet. So all of my verifications, the assertions that it makes, are all supposed to fail. And in particular, I have this one, if you run it with the config command, what it'll do is it'll actually download the config, and I can show you the code and spend a little more time on it a little later if you'd like, where we actually download the config, and I make these assertions based off of what I see in the config. I expect, and again, for every service I see in Kubernetes, it's all driven by the services that are passed in. This variable services is the list of Kubernetes services. So I literally need to make sure that all of these configuration snippets are here based on the services that I retrieved in real time. And so if somebody spins up a new service, but I haven't applied the policy correctly, this will fail. And that's why it's failing now, because I ran this script before I actually applied the policy. So let's go to the second one. The second one is actually pretty interesting. I have some references to a few things. There's a few things we can do with respect to state-centric. So the first thing is config-centric. This is a little closer to real world, but it's still pretty network engineering-centric, meaning it's important to us as network engineers, the sort of the details that we need. But it's a little more realistic because it's a little more real-time. You can verify things like, I want to make sure that all the BGP peers actually exist and I'm seeing routes. If you expect a certain number of routes to constantly be installed on your router, you can perform verification on that. Interface statistics, things like that. And the cool thing here is there's a bunch of tools that you can use to do both of these things, streaming telemetry being one. You could always stream the telemetry and perform assertions there. Or you could go get some information based on either SNMP or some other tools that I'll show you here in a second. And you could perform assertions on that stream telemetry. So I have a few things built here. If you just use the keyword operational, let me go back to my terminal. So you can see I ran the same verification script, but I used the keyword operational. This runs through something called Napalm Verify. So Napalm's a really thin sort of abstraction on top of vendor device APIs. And what we're doing here is we're saying, hey, I have all of these different Napalm methods, like paying a device, get the facts about this device. I have this description of what I think the state should be at. And again, it's in real time, informed by Kubernetes. Is it that? And give me a compliance report. So this compliance report is actually generated by Napalm for us. And this top-level complies key in this dictionary will say true if everything complies. And so all you have to do is describe what we think the information should be at. If there's a deviation, this will get set to false. And so in my script, I say, I assert that it's true. And of course, if it's false, the script breaks, which it has, because again, the policies haven't been applied. So the last interesting verification portion, super passionate about this part, because again, it's very representative of what applications actually see. What would be great is if I could determine what kind of connectivity Kubernetes is requiring to get to your applications, and then actually query them. Actually go to those applications with actual traffic based on like what users will actually do. So what I've done again is in real time I retrieve the details of what's running in Kubernetes, and I say, look, what I would really love to do is actually generate HTTP traffic for every single one of these services from the Bastion VM. And again, the whole point of this is to power the policies that I've written into the VSRX. And so these all fail, actually. There's no metrics retrieved. I'm using an open source tool that I built called Todd on the Bastion VM. And what it's doing is it's saying, like, I have these 6 agents, and I want to run HTTP traffic from all of them. They happen to all run on the Bastion VM, but there's no reason they couldn't run elsewhere. You could have 6 virtual machines spread across the country if you wanted to. But it didn't retrieve any metrics because it didn't work. It's not passing traffic through the VSRX according to the policies because they're not installed. All right, so let's get to that cool part. So if you go into the README, you can see that there's a step here where you can actually run. So I see initial verification. You run through all of the 3 steps that I just mentioned. If you run this little doohickey, config firewall.py policy, what it's doing again is it's querying Kubernetes right now. And it's getting the list of services. And when it's done, it's going to generate a config snippet for the VSRX based on the interfaces the policies need to be applied to, or what zones those interfaces need to be in, and then the policies, what ports need to be allowed, what applications need to be defined, things like that. Again, all in real time, generated in real time. So should be done. But the real test is rerunning our verifications, right? That's the real test. So let's do that. So I'm going to just do up until I get to the verification demo. And I'll just go step by step. Config first. Again, download the config from VSRX. Go to Kubernetes, ask it what services it needs, make sure the 2 pass. All my assertions pass. I need to make sure that the applications are defined in the VSRX. Done. Check that the policy definition and proper references are there. Again, applying to them into the right zone. Done. And making sure that the zones are actually on the interfaces that they're supposed to be in. Done. All assertions passed. Real simple example. Certainly it can get way more robust than this, but it's a nice illustration. So next, operational. So operational is, again, querying the VSRX for its like sort of current state. Again, it generates this. This is a Napalm verify YAML file. I'm not making you deal with the files. I'm generating this because I'm actually using Kubernetes as my source of truth. So this isn't even stored in the file system. It's all in memory because it doesn't need to get stored. We don't need files anymore. We just have the API as the source of truth. And then, of course, the compliance report complies equals true.
Oh, I see.
Yeah.
Yeah.
All right, last step.
Now I got it.
So I'll just redo this and say traffic.
I'm a bit slow.
We're all slow by comparison.
So if you look at the assertions that it's happening, it's just going through this is like Todd specific stuff. Again, it's spinning up all of the agents and saying, like, I want you to generate all this HTTP traffic. And I'll go to the script actually while that's running because it does take a few seconds. If you look at the traffic verification step, again, iterating through all of the services and saying for every service, I want to generate test run information. And here's the important part, because it's the assertions that we actually care about. I need to assert that the traffic is actually being passed the way I think it is. So the first thing is I want to assert that I have targets. Obviously, I want to know that I've ran the test. But more importantly, I want to assert that the HTTP code being returned for every single agent's interaction with that Kubernetes application is 200. It verifies a whole bunch, right? Not only is the network working, layers 1 all the way up through 7, right? We got HTTP working. Everything on top of that is working, and the application itself is working because we got a 200 error code. It doesn't go all the way to the top. It doesn't actually do application interaction.
You could easily extend that probe to be much more sophisticated. You could start
Precisely.
You could use an appropriate API call, which would start to load data into forms and
Yeah.
click OK, and if the response comes back,
Yeah.
you have to get deeper into.
Yeah, and this presentation isn't really about Todd, but that's exactly how Todd's built. Like,
Yes.
you can just define your own and pop it in and be done.
Yeah, that's right. You get more sophisticated, but a 200 code is a great place to start.
Yeah, and the cool thing here, again, is we're performing these assertions. We don't know where the application is. We don't know what ports they're running on. Has anybody seen an IP address or a port yet?
No, all came out of Kubernetes.
No, because we retrieved it programmatically, so it just doesn't matter. It literally doesn't matter. What matters is the assertions we're making here. And those don't change. We know that the status code needs to be 200.
Yep. You didn't have to have somebody go and configure the YAML. You're pulling all of the configuration, like the detailed configuration, the bottom-up configuration, directly from the Kubernetes database.
Yep.
So you're saying, oh, there's web servers. Make a call to the Kubernetes to get on the API to say, give me the IP address of that.
Yep.
And then you're saying, then I'll go and probe them all.
100%.
Because at any point in time, that container could go. It could be spawned, it could be one container, it could be 50 containers.
Yep.
You're never going to know. So whatever your probe's going to be is going to vary over time. It's going to be a temporal challenge. So you have to use the only source of truth in this is going to be Kubernetes.
Yep.
Or the Kubernetes.
Yeah, and it didn't write itself, right? This Python script is human logic at the end of the day, right? We're human beings. We know what network policy should be applied. We know where we should get that source of truth. And the applications folks aren't going to be writing this network verification stuff.
Yep.
So it's still firmly within the network engineering domain. The information is there. Go get it.
And where it gets very interesting is when you start doing the reverse.
Yeah. Yeah.
You know what I'm saying? Being able to discover what's there and then be able to say, okay, this is what should be there, this is what's there. How do I reverse and enforce policy?
Yeah. All right, I know we're short on time. I have a few more slides, but they're not really important. This is the bulk of it. Guys, thanks so much for having me. It's a great pleasure to see everybody. Everybody on the stream, nice to see you as well, virtually. Thanks.
Thanks.